Welcome to Lesson 12-4, Compound Events. Our Indiana Academic Standard is 7.4.5. Our first vocabulary word is compound event. A compound event is an event that consists of two or more events. Two events are independent if the occurrence of one event does not affect the probability of the occurrence of the second event. And two events are dependent if the occurrence of one event affects the probability of the occurrence of the other event. Pause the video at this time so you may finish copying down the definitions. Now I want to talk about some examples of independent events. Independent events, in simpler terms, are things where one item doesn't affect the other item. For example, when you roll dice, what you roll the first time has no bearing on what the second die is going to be. Or if you roll dice one time and then you roll it again, there's no bearing. It doesn't change your outcome. Spinning a spinner is the same situation. When you spin the spinner the first time, the second time you spin it, it's not going to affect it. If you flip a coin, same scenario. It's not going to change the probability of the second event. If you pull a chip out of a hat or a marble out of a bowl or something, if you return the first chip before pulling the second chip, it's not going to have any bearing on the events. Dependent events, on the other hand, are different. Dependent events, the outcome changes when you eliminate a choice. For example, if you're drawing names out of a hat and you don't replace a name, if you're drawing out who's going to go first, who's going to go second, when you draw the first person's name out of the hat, that probability of the second person or the second name being drawn is going to change. We saw that when we talked about the probability of Katniss winning the Hunger Games. When we drew out when we found the probability when everyone was in the game, it was much different than we found the probability at the end of the game when there were only 3 people left in the game. Pulling chips out of a bag without replacing the first is another good example of dependent events. Now, to find the probability of 2 or more compound events occurring, you're going to multiply the probabilities of each event. Now, if we're talking about independent events, if A and B are independent events, then the probability of A followed by the probability of B is going to give us our total probability. So we're going to take the probability of A times the probability of B, and that will give us our probability of both things occurring. Now, if the events are dependent, if the first one affects the second one, you find the probability of A, but then you're going to have to find the probability of B after A has been drawn. Again, if you need time to go over any of this or get any of this copied down, now is a great time to pause the video. You may repeat things. Don't forget, you can rewind. Listen to it again if there's anything you don't understand. Now we're going to try our hand at some examples. We have a spinner, has equal sections labeled 1 through 10. You're going to spin the spinner twice. We're going to find the probability of getting a 2 followed by a 5. The 2 events are independent. There are 10 possibilities on each spin. So we'll find the probability of 2 and the probability of spinning a 5. The probability of spinning a 2 is 1 out of 10 because there's 1 2 out of 10 choices. The probability of spinning a 5, again, is going to be 1 5 out of 10 choices. So now we simply multiply. 1 times 1 is 1, and 10 times 10 is 100. So the probability that you will spin a 2 and then a 5 is 1/100th. So the correct answer is choice D in this example. If you need more time to write any of this down, pause the video. We're going to find another example. We're going to find the probability on this spinner, if you spin twice, the following. The probability of getting a prime number followed by the probability of getting an even number. So we have to find the probability of a prime times the probability of an even. Well, there are 4 prime numbers between 1 and 10 out of 10 numbers. There are 5 even numbers out of 10 numbers. When we multiply this, we get 20 over 100, which needs to be simplified to 1/5. Again, at this time, if you need to stop the video, stop, make sure you are all caught up on your notes. Now we're going to look at some dependent events. If you select two cards at random from those with the letters on them as shown below, the two cards do not show vowels. Without replacing the two cards, you select a third card. Find the probability that you select a card with a vowel after you select the two cards without vowels. Well, if we pulled two cards out of the word probability, we would only have 9 remaining cards after the first two cards were selected. So there are 4 vowels out of the cards, and there are 9 cards remaining. So the probability of selecting a vowel for the third card is 4/9. A bag contains 3 red marbles, 4 white marbles, and 1 blue marble. You draw 1 marble. Without replacing it, you draw a second marble. What is the probability that the 2 marbles you draw are red followed by white? The 2 events are dependent. After the first selection, there are 7 marbles to choose from. So we're going to be finding the probability of a red followed by a white. So we first find the probability of red, and then we'll find the probability of white after red. So the probability of red was 3 red marbles out of 8 possible marbles. After we draw that first marble, there's only 7 marbles left. 4 of those marbles are still white because we haven't drawn a white marble. But we have 7 marbles left. So we multiply 3 times 4 and we get 12. And 8 times 7 is 56. We simplify that to 3/28. So the probability the 2 marbles are red and then white is 3/28. At this time, you can pause the video before you go on to the next lesson or the next problem. We'll do the quick check. You and a friend play a game twice. Assume the probability of winning is 1/2. So we're going to find the probability of winning and then losing. If your probability of winning is 1/2, then your probability of losing is also 1/2. So the probability of winning is 1/2. We're going to multiply that by the probability of losing, which is also 1/2. So 1 times 1 is 1, and 2 times 2 is 4. So we end up getting a probability of 1/4. Now think back to that example where we had the word probability written out on cards. We're going to select a B card at random. Without replacing the B card, we select a second card, a probability of Y. So right now we're just finding the probability of Y, but we've already selected a card. So there is 1 Y, but instead of there being 11 cards, we've taken out one of the B's, so there's only 10 cards. So the probability of getting a Y on our second card is 1/10. Now for sample 3, we're going to think about the card, 26 cards labeled A through Z that are in a bucket. We're going to select a card. We're not going to replace the first card, and we're going to select a second card. We're going to find the probability then of J followed by M. There's 1 J in all of the letters out of 26 letters. Then we're going to multiply that by the probability of pulling out an M. There's only 1 M, but now instead of being 26 cards, there are only 25 cards left in the bucket. So 1 times 1 is 1, and 26 times 25 is 650. So the probability of drawing a J followed by an M is 1 out of 650. Now's a good time to pause the video, rewind it if you have any questions. We're going to do one more example. This one I really want you to try on your own. So I'd like for you to pause the video after each little bit to make sure that you're doing it correctly. You spin a spinner twice with the numbers 1 through 12 on the spinner. Find the probability of getting an odd, then a prime number. You have to think first, is this dependent or independent? You're right if you said it's independent, because spinning a spinner is not going to have any effect on either spin. So first, write down the probability of getting an odd number. Think about that for a moment and write your answer down for the probability of getting an odd. Go ahead and write your multiplication sign. Now think about the probability of getting a prime number. Write that fraction down and go ahead and multiply it. You should have gotten 6/12 for the probability of an odd, 5/12 for the probability of a prime. So 6 times 5 is 30, 12 times 12 is 144, which simplifies, make sure you always simplify, to 5 out of 24. Now we're going to take a look at another example. In this example, you're picking marbles out of a bag. There are 4 red, 5 blue, and 6 white marbles in the bag. You do not replace the first marble. Find the probability of drawing a red, then a blue. Before you can begin this problem, you really need to think about, is this a dependent situation or an independent situation? We're not replacing the marbles, so that would make it a dependent situation. So we're first going to figure out the probability of drawing a red. Write down what your probability of drawing a red is at this time. You should have come up with 4 red marbles out of 15 marbles total. Now we're going to multiply that times the probability of drawing a blue. But remember, we're not replacing the 1 red marble we drew. So please write down now your probability of drawing a blue. There are 5 blue marbles, but there are only 14 marbles in the bag because we didn't put back the first marble. So we now need to go ahead and do that multiplication. 4 times 5 is 20. 15 times 14 is 210. We then need to simplify this. When we simplify it, we get 2 out of 210. I'm sorry, 2 out of 21. 2 out of 21 is correct. If you want to do some practice, you can do the online quiz at phschool.com. It's ARA1204. It's good practice, and don't forget you can print them for extra credit. Look for an activity lab 12-4. Hopefully I'll have it on Edmodo, and that will give you additional practice.